Additional counting techniques will be covered with this particular example. The example has to do with coin tossing. We all know that when a coin is tossed, there are two outcomes, either heads or tails. We're not looking at the probability of heads or tails occurring, just the fact that a head could occur or a tail could occur. So now let's take a look at if a coin is tossed twice. So if a coin is tossed twice, the results could be two heads, a head or a tail or a head, or a tail and a tail. Yes, we'll distinguish between if a head or a tail occurs first when we have heads or tails. Those are two different outcomes. All right, so when we toss a coin twice, there are altogether 4 different results. Now let's take a look at taking a coin and tossing it 5 times. First, let's figure out how many outcomes there would be if we disregard, if we're wanting to know 5 heads showing up or 5 tails showing up. So just in general, if we tossed a coin 5 times, how many different outcomes are there? Well, we know that a coin has 2 sides, so that's where this 2 is from. There are 2 sides, and we're tossing it 5 times. That's my exponent. And 2 to the 5th is 32. So there are 32 outcomes when a coin is tossed 5 times. And I could, if I wanted to, list all the different ways those different coin tosses could occur, but 32 outcomes is a long and tedious thing to do. So it's best to have arithmetic to figure out that there's 32 outcomes. Now knowing that, let's take a look at question B. It says, how many outcomes will have exactly 4 tails? Okay, we want exactly 4 tails. That means out of the 5 tosses, we want 4 tails. The combination that we're going to do is a combination of 5, because there's 5 tosses, and we want 4 tails. So a combination of 5 taken 4, and that answer is 5. Part C, how many outcomes will have exactly 5 tails? So we want 5 tosses, and we want 5 tails. This means we want the combination of 5 taken 5. And that answer is 1. There's only one outcome that gives us exactly 5 tails when we're tossing the coin 5 times. Let's go up to part B again. It had said how many outcomes will have exactly 4 tails. And we had that situation, there were 5 different ways. And the reason is that I could have tail occur at the front end of my tosses and then a head. Or I could have 3 tails, a head, and a tail. Or I could have 2 tails, a head, and 2 tails. Let's see, I could have a tail, a head, and 3 tails. Or I could have had the head occur first and then 4 tails. So we can see that there are 5 outcomes. When they are all tails and we're tossing them 5 times, there's only one way to do that. In part D, we're going to take a look at using the complement rule. You've used the complement rule in other problems and lectures. So here the question is, how many outcomes have at most 3 tails? So we want to look at situations where there's either 0 tails, 1 tail, 2 tails, or 3 tails at most. You can see that that would require 4 different calculations. So another way to do this is to look at the opposite of having at most 3 tails. And that would be having 4 tails or 5 tails. The opposite of at most 3 tails is to have more than that, 4 tails or 5 tails. And then subtract those answers from the universe. Now earlier in part B, I had found out that their number of ways to get 4 tails was 5, right here. And in part C, the way to get 5 tails is 1. And also back up in part A, we found out the total number of outcomes in the universe, which was 32. And if we do our arithmetic, 32 take away 5, take away 1, gives us an answer of 26. There are 26 ways to have at most 3 tails. So problems will frequently be set up in such a way that by the time you get to either a part B, C, or D, that they build upon each other. And make sure that you're thinking of complement rules to make your work easier.